Can I start it?
Yes, please. Please.
Okay. So, guys, hello everyone. Thank you for coming and joining us for this event. My name is Sima. I'm organizer. Our ladies, actually, our ladies Urmia organizer. I think for the 3 or 4 years, I don't know. I'm so happy, so happy for being here among of you, and I hope that these events that we prepare can lead to improve this diverse community specific for the women. And yeah, as you know, this event is about the introduction for the introduction of tidy modeling with our book. So the introduction has a 3 section, and I want to start each section and introduce them. So for this job, just I stop my video. Okay. So guys, the introduction to tidy modeling. Okay. So the first section is about software for modeling. As you know, mathematical models simplify complex systems to capture data, relationships, driving predictions, the decisions, and daily application like weather forecast, shopping, and spam filtering. They are now indispensable with both actually beneficial and controversial impacts. And models are so easy due to abundant software and easier data capture and storage. This is the point. So this chapter focus on the selecting or building modeling software, ensuring actually mathematical correctness and understanding models' role in data analysis. Modeling software actually must have many points. For example, must be a user friendly to avoid errors, as poor interfaces can lead to serious consequences. So for many modeling, such as misidentified data affecting clinical trials and so on. High quality software should guide users toward correct practices effortlessly, embodying the PET of success principle for seamless and accurate use. So I have to say this book focus on our potential, actually powerful, extensible open source language tailored for the data analysis, modeling, and visualization. Well, it highlights the two important packages, Tidyverse and the Tidy Models packages, designed for the high quality, user-friendly modeling, as I told you, a taxonomy of models, starting with the, descriptive models shows how they illustrate data characteristics like detecting artifacts in the microarray data to improve the results. So this is the point. This practical guide emphasizes tools that balance power with accessibility, ensuring reliable modeling outcomes. So descriptive models actually like I don't know, the word is right, loose, LOESS, reveal. So guys, just I have to say here that this presentation and this event, it's so general, so you have to study more and more that this book, because this book have many details. So this is the important thing. Reveal actually descriptive models like LOES, LOEESS, reveal trends and relationship in data, aiding variable representation. Inferential models test hypotheses or answer research questions, relying on assumption to produce outputs like for example, p-values or confidence intervals. Actually, this accuracy depend on data alignment with the assumption, with validation often delayed, as seen in the clinical trial, where real-world results confirm initial findings only after years. So for the second, predictive models aim to provide accurate forecasts for new data, prioritizing the precision of the predicted values over, inference or the result. I mean, for example, a book buyer might predict how many books to order to balance cost or and profits. Predictive models can be mechanistics using principle and assumption. For example, drug absorption modeled with differential equations, or empirical relying on the machine learning techniques like k-nearest neighbors, that is the KNN, to make data-driven prediction. Mechanistics model depend on the assumption, but allow quicker feedback through data validation, while empirical model focus on the prediction accuracy without actually limitation on the strict theoretical assumption. So models are classified, as you know, by their use rather than mathematical properties. Linear regression, for instance, can be descriptive. Inferential, like ANOVA for p-value, or the predictive, that is the two classification of the models. So some predictive models like a KNN, lack of the mathematical structure for results, and even inferential models such as logistic regression can fail if their predictive accuracy is poor. So this is the important point, the accuracy. Statistical significance alone doesn't guarantee model appropriateness if predictive performance is weak. So this is the second most important point for that, actually. So models are categorized as you can see in the slide, as a supervised and unsupervised. Unsupervised model like PCA clustering identify patterns without a dependent variable, while supervised models like a regression neural network predict outcomes, either numeric or categorized or classifications. Supervised modeling relies on predictors. It depends variables to forecast outcomes. Dependent variables. Well, I have to say, data variables are categorized as a quantitative and qualitative. Quantitative, like a real number, or qualitative, like a categories like a red or blue, the color, or any categories. So modeling is not the first step. So this is so important for the modeling, actually. Modeling is not the first step in data analysis. It follows critical preliminary phases. Data cleaning ensure the data's accuracy, relevance, and the applicability, often overlapping with exploratory data analysis, EDA, which checks relationships, distributions, and potential biases. Understanding the data's source and the appropriateness is essential. Before modeling, clear goals and performance metrics, such as accuracy or error rates, must be defined. So this is important. I say again, before modeling, clear goals and performance metric, such as accuracy or error rates, must be defined. The process is iterative, requiring repeated cycle of transformation, modeling, and visualizing. Guys, the modeling process is iterative, involving several phases as a cycle modeling. For the first one is the exploratory data analysis, as I told you, that is EDA. That is initial back and forth analysis using numerical method and visualization to uncover insight and raise further question. For the second point is the feature engineering, that is insights from EDA, exploratory data analysis, lead to creating specific model terms, such as complex features like a PCA or simpler constructs like a predictor ratio. So guys, follow us, because the detail of this point is in the chapter 8. So for the third point and the third phases is the model turning and the selection. That is, multiple models are generated and compared. So some requires parameters tuning with the repeated data splitting during resampling. So guys, the detail of these phases is on the chapter 10. For the last phase is about the model evaluation, about the performance metrics, residual plots, and EDA, like analysis assess models effectiveness. Formal compression help determine if differences are meaningful or the noise driven. And also for the last phase is on chapter 11. So guys, follow us for the other events. So this process often cycle, as I told you, through these steps to refine the model. Actually, this model is the cycle steps. So for the summary of this section, the modeling process is iterative, refining model through the repeated cycle of the EDA, feature engineering, and model evaluation to identify superior model and address poorly estimated data subpopulations. After achieving analysis goals, the model is finalized, documented, and communicated. So this is the 3 important point of this cycle. Predictive models often undergo final validation using reserved data. So guys, the second section is about a tidyverse primer. So the tidyverse is a collection of our packages designed for data analysis, as you know, sharing common principles to streamline learning and usage. It aims to facilitate efficient communication, actually, between human and computers in data science. So tidy models, part of this ecosystem, applies tidyverse principle to modeling, promoting usability and sound statistical practices. Together, they integrate with and build upon the core R language. So while based R requires complex syntax like order function, the tidyverse offers simpler, user-friendly. As I told you, this is the important benefit actually for the tidyverse, user-friendly alternatives. These principles ensure R is approachable for analysis and the modelers, not just developer. And actually, base. So we are for the others actually slides. We have many examples. For the first one is about the sorting data in tidyverse. Guys, I don't have actually our studio in my computer. So in the last of this slide, I have a summary of all the codes, and I can provide you the files, and you can use it in your R studio for more examples. So sorry about that. So for the sorting data in the tidyverse, base args order function is computationally efficient but not user-friendly. While the tidyverse deep layer, as you can see here, deep layer packages actually provides the arrange function, which more intuitive, allowing user to sort data directly by specifying column name. Okay, as you can see here. Okay, allowing user to sort data directly by specifying column name. This aligns with the tidyverse goal of creating accessible and human-centered tools. So as you can see here, the pipe operator, this one, enable chaining our function for cleaner, more readable code. So the most important thing and the point of the pipe operator is the for cleaner and also readable code. For example, as you can see here, we have an example for actually sorting math cars by year, as you can see here. And keeping the first 10 rows can be written compactly without actually intermediate variables. So this is the example. And also I wrote the explanation of the tidyverse actually packages about the deep layer. So also I have to say about the, okay. Also, I have to say this functional programming style align with the tidyverse principle. As I told you, for the intuitive and the efficient workflow, similar to the ggplot2, which layers plot component, and the pipelines allow for the smooth workflow even when return objects different. Okay. The second one is the creating custom function, actually functional programming. So this is actually this method, I don't know, this method encourages written function with no side effects, where outputs depend only on inputs. This is the example of this thing. For the explanation, the core package provides the MAP or the map function family for functional iteration. So for the third one, creating bootstrap samples, the resample packages in the tidyverse, for example, as you can see here, the packages. For example, packaging the tidyverse facilitate data resampling, such as cross validation or the bootstrapping. Resampling function return a table with a splits column containing the resample data set. Okay, this is the point for the actually resample bootstraps. So you can see we have explanation for that, and explain for this example. And for the others, specialized data structures lack of the flexibility needed for the complete modeling workflow, unlike common structure like tables. In resample, the splits column is a list containing resplit, or a split, I mean, as you can see here, just I want to show you. Okay, for the list column, okay, object which store now information for bootstrap samples. These list column are the powerful for data analysis and are central to the functionality of the tidy models. This one, okay, this one is about the poor. Okay, the tidyverse approach benefits users by using common data structure like table, enabling compatibility with a vector-based function, like as you can see here, Urmia. Okay. This flexibility allows a user to easily add column without altering the data class. However, this generality may sacrifice computational efficiency compared to the specialized data formats such as STF for chemical data or the sparse matrix for the binary data. This specialized format, Excel, is actually normally defined context, but lose their advantages if the data change or require border processing. So I think that for the last one is the broom. That is the tool for the standardization. Okay, Broom packages converts actually R objects, like for example, correlation test results into consistence table for the easier use in workflows and the visualizations. Okay, here you can see the example of these that use the Broom tidy with the correlation results. These standardized table with actually key value for easier integration and analysis. As you can see, the Broom tidy for the converts object into table for consistent formatting. Okay. So, okay, for the last point of this section, the second one. So, tidyverse pipeline reads and process data efficiently. As you saw the pipeline, it has a many actually feature that I said actually for the most important of them. The first one is the read data, as I told you, that we can use this function. Okay, for the select and the rename column, we can use select for the transform data using mutate. And for summarize group data, we can summarize or the grouped by. And also for all these points, we have an example here. Okay. Okay, I just I have to say the tidyverse advantages. Okay, actually the summary of the whole this section simplifies complex workflow into the readable pipelines, and for the second one is the focus on the user-friendly syntax and the tools making R more accessible, and also for the last one is the enhances or the improving modeling workflows by adopting similar principle for the consistency and the easy of the learning. So, very sorry. I need some water. Okay. For the last section that is about the review of the modeling fundamental. So guys, before diving into how tidy models applies tidy data principles to modeling, it is useful to understand core R conventions for creating training and using models. Actually, these conventions rooted in the S languages. In the book, we have references for S languages from the White Book, actually. You can search about it. The White Book includes symbolic model formula, model matrix, data frames, and object-oriented methods for data analysis. While these interfaces remain fundamental, they have seen little change over time and are key to understanding R's modeling infrastructure. For the first actually package or the method, so to fit a linear model in R, they commonly use LM, I think, LM function, as you can see here. LM function requires a symbolic formula, as you can see here, rate, temperature, and a data frame containing the data. So I have explanation for this function. Actually, the formula specifies the chirp rate is the outcomes, with temperature as a predictor. So temperature is a prediction. If the data sets includes a column for the time actually of the day, okay, the formula become the rate, temperature, time here. Rate, temperature, without spaces, the time, okay. Incorporated both temperature and times as a predictor. So the temperature and time is a prediction. So the formula that the specific one is the rate, temperature, spaces. Okay, represent the temperature and the spaces as a separate main effects in the model, where a main effect refers to a single predictor variable. Actually, for two-way interaction, the model can be fitted in R using, here by two data creates. The output listed coefficient, including interaction terms, actually are combines variable and the factors level into a single label without actually delimiters. For example, I have an example here, temperature plus spaces by two space phase main effects and two-way interaction. It also encodes spaces as an indicator variable and multiplies them by the temperature for interactions. This actually functionality highlights the dual purpose of the defining predictor and the encoding data. So predictors and encoding data, which is crucial for the feature engineering and handling complex model. So for the second one, that is about the, as you can see, checking model diagnostics. Before going into any inferential results for the model, the fit should be assessed using diagnostic plots. We can use the plot function, as you can see here. For the LM object, this method produces a set of 4 plots for the object, each showing different aspects of the fit. So as you can see here, plot interaction fit, which equal to the 1 shows residual versus predicted values to assess linearity and I don't know the pronunciation, homostasticity. I don't know the meaning of this actually. Sorry for that. And for the second one, that is about the plot interaction fit, which equal to 2, generate a normal quantile plot for the residuals to evaluate normality. So for the comparing we can use the ANOVA. Our uses actually lazy evaluation, meaning computations are performed only when necessary. For example, the coefficient table for model terms is not automatically calculated and requires the summary method or the summary function that determine if the interaction term is necessary. The model should be recomputed without the interaction term. The ANOVA method or the function can then be used to compare models and assess whether including this interaction term significantly improves the fit. So we can use the ANOVA to compare models. So for the making prediction, actually, the interactions term was tested by the comparing model using the ANOVA, as you know. So showing a p-value, for example, indicating no evidence to include the interaction. Actually, model prediction can be made with the predict function, as you can see here, as demonstrate for O examination chirp rate between 15 and 20 centigrade. So this is the model for the prediction. Also, R's formula, syntax, and tools like ANOVA, summary, and predict simplify model specification, evaluation, and prediction. Okay, summary, ANOVA, and the predict. So the framework, actually this framework established in the 1992 remains a powerful and relevant approach for the data analysis. For the last thing that I have to say about this section as a summary, so we can ask yourself, ourselves this question: what does the R formula do? The R formula serves multiple purposes in modeling. For the first one, define the column, encoded column, and also specifies rules of column. For the defines the column using the model, encoded columns into appropriate formats, such as creating indicator variables for the factors and interactions, and the specify rule for the column, for example, predictor and the response variables. Well, unlike Python's philosophy of the, one abuse way, R's flexibility enable evaluation and adoption to varied use cases, actually, accommodation, different user performance, and preference and problem requirements. So this is the important point about the R, unlike the Python. And while R's, syntactical diversity offers, flexibility, it is often stems from the catering to developer needs over user needs, leading to inconsistency among packages. For example, for instance, in modeling projects with binary outcomes, generating class probability estimate typically involves as a predict method, However, they require arguments for the predict function very significantly across, models, making it challenging even for the experienced users to navigate. So for the conclusion of, this time and the introduction of this book, I have to say that tidy models and related tools address R's inconsistence by enforcing user-centric design, promoting seamless modeling workflow, and standardizing outputs for usability. So as you can see, Here I put some summary of this code and function and method and packages. I can provide you this file and use this actually function for yourself and for your project if you want. That is so useful. And guys, thank you for patience and for being here. Thank you a lot. I can stop sharing here.
Thanks,
Okay.
dear Sima. It was wonderful. Yeah, we really enjoyed. You are speaking very fluent,
Thank you.
very good. Thank you so much. And one thing I want to add, you asked about the homoscedasticity. It's like it's term in statistics, which first of all we say if the data is like heteroscedastic or homoscedastic. Okay,
Okay.
so when our data is homoscedastic, it means the residuals. What's residual? For example, you have one forecast data and one observed data. When
Okay.
you are like you want to um, like look at these two data, and residual is the difference between these forecast and like observed data. So when these errors are spread evenly across all values of the predictor variable, we say our data is homoscedastic.
Okay.
But when it's heteroscedastic, it means the variance of these residual changes. So it may increase or decrease with the predictor. So it's kind of in Persian we can say it's like they say hamsan ovari or
Okay.
hamsan or no hamsan. So it's all about the variance and these residual things.
Okay,
So
and also I have to say this that guys, I don't I didn't actually do any project with R actually because I don't have any R courses in my field. So sorry for the I don't know many things, and thank you for clarify this. And
no worries.
yeah, thank you.
Also, we can most of, because both R and Python are very important, and
Yeah,
actually we tried to create PyLadies as well, but we failed. So
yeah.
that's why we can add maybe we can add some courses also very close to uh, like integrating R and Python together, and we will try to add also in our next mm, sessions. Thank you so much again, Sima,
Thank you for your.
John. Let's see if anybody wants to ask any questions.
Yeah.
I- So or anybody wants to add a comment or something,
Yeah, any
and
comment?
obviously,
Anything? I'm so basic and you are so professional, guys.
no worries.